In this video, we're going to solve radical equations. In step 1, make sure the radical is isolated. If not isolated, you need the radical on the side by itself. Step 2, raise both sides to the same power to undo the radical. Step 3, we're going to solve for x. Step 4, check your answer for extraneous solutions. In example A, you're given square root 4x plus 2 equals the square root of 3x plus 4. Because it's a square root, we know to undo it by squaring both sides. Once we square both sides, this turns into 4x plus 2 equals 3x plus 4. From here, subtract 3x from both sides. 4x minus 3x is x. So you're left with x plus 2 equals 4. Next, subtract 2 from both sides of the equation, and x will equal 2. Now, we're going to rewrite the original. 4 instead of x, I'm going to put a 2 in parentheses in the place of x, because our x that we solved for is 2. Now, 4 times 2 is 8, and 8 plus 2 is 10. So on the left, I have the square root of 10. On the right, 3 times 2 is 6. 6 plus 4 is 10. So 2 is the answer to solve example A. Alright, let's look at example B. In example B, you're given 2x plus 1 equals negative 3. The radical is on the left, a negative 3 is on the right. We're going to square both sides because we're undoing a radical. The left side turns into 2x plus 1. Please remember, to undo a square root, you raise it to the second power or you square. So 2x plus 1 equals positive 9. Negative 3 times negative 3 is a positive 9. Or a negative 3 squared is a positive 9. From here, you have an equation that says 2x plus 1 equals 9. Subtract 1 from both sides. So 2x will equal 8. Divide both sides by 2. X will equal 4. When you check your answer, we're going to replace x with 4. 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3, which means 4 cannot be our answer. So this, example B, is no solution because 4 is extraneous. Alright, let's look at example C. Square root of 3x plus 1 minus 5 equals 0. The radical is on the left, and there's a minus 5. Let's go ahead and add 5 to both sides. Square root 3x plus 1 is going to equal 5. Now, I can square both sides because the radical is on the side by itself. Undo the radical by squaring. So 3x plus 1 equals 5 squared, which is 25. Subtract 1 from both sides. 3x will equal 24. Divide both sides by 3. X equals 8. We're going to take 8 and plug it in, or replace x with 8. 3 times 8 is 24, plus 1 is 25. The square root of 25 is 5. 5 minus 5, is that 0? Yes. So again, x has to make the radical equation true in order for it to have a solution. So for example, C, the solution is 8 for x. In example D, you're given the square root of 17 minus x, that's under the radical, minus 3 equals x. Now, we have to isolate that radical. We do that by adding 3 to both sides of this equation first. So square root of 17 minus x equals x plus 3. Now we can square both sides. 17 minus x, because we undo the radical, equals x squared plus 6x plus 9. If you're wondering where I got that from, x plus 3 times x plus 3, x squared plus 3x plus 3x plus 9. So x squared plus 6x, because you combine like terms in the middle, plus 9. It turns into a trinomial. Please remember, when you have that binomial squared, the same binomial, and you square it, it turns into a trinomial. From here, I'm going to set the quadratic equation equal to 0, which means I have to move everything to the right. So let's start with the 17. So let's subtract 17 from both sides. I'm left with negative x equals x squared plus 6x minus 8. Then I'm going to add x to both sides. Remember to combine like terms. So 0 equals x squared plus 7x minus 8. The x has to add to the x term. From here, we have to factor. In the top is a negative 8. In the bottom is a 7. Two numbers that multiply to equal negative 8 and add to equal 7 are 8 and negative 1. X plus 8 equals 0. X minus 1 equals 0. When you solve, x equals negative 8. X equals positive 1. Now the question is, do both of these numbers work to solve this equation? Under the radical, 17 minus a negative 8 minus 3 equals negative 8. Your second setup is square root 17 minus 1 minus 3 equals 1. Now, 17 minus a negative 8 is a positive 25. So square root of 25 is 5. 5 minus 3, does it equal negative 8? No. 5 minus 3 is 2. So we know negative 8 is not a solution to solve this equation. Square root, under the square root you have 17 minus 1. So on the right side you have the square root of 16 minus 3 equals 1. The square root of 16 is 4. 4 minus 3, yes, it equals 1. So x equals 1 is the only solution to solve example D. Again, it's the only solution to solve example D. In example E, you're given the square root of 2x minus 4 equals x minus 2. This one is already isolated, so we're just going to raise both of them to the second power. Undo the radical, so 2x minus 4 equals x squared minus 4x plus 4. Hopefully you remember that binomial squared turns into a trinomial. From here, we're going to set the quadratic equation equal to 0. So first, subtract 2x from both sides. So negative 4 equals x squared minus 6x plus 4. Then add 4 to both sides. So 0 equals x squared minus 6x plus 8. We set the quadratic equation equal to 0 because so that we can factor and solve. You want to make sure that x squared is also positive when you're doing this. Now you factor. There's an 8 in the top, a negative 6 in the bottom. Your two numbers are negative 4 and negative 2. So x minus 4 equals 0. X minus 2 equals 0. X minus 4 equals 0. Add 4 to both sides. That's why x equals 4. You will do the same thing with x minus 2. Equals 0. Add 2 to both sides. So x equals 2. Remember, factor, solve. So your two x's are x equals 2 and x equals 4. We're going to take both of those and we're going to plug it into the original equation. Square root 2 times 2 minus 4 equals 2 minus 2. And then the other one is square root 2 times 4 minus 4 equals x minus 4. Well, excuse me, 4 minus 2. Two times 2 is 4. Then 2 minus 2 is 0. So 4 minus 4 is 0. So x will equal 2. On the right side, 2 times 4. So 8 minus 4 is 4. 4 minus 2 is 2. The square root of 4 is 2. Yes, 2 equals 2. So this one has two answers. X equals 2 and x equals 4.